Happy Tuesday, everybody. Mr. Markwart here with you once again. We are going through Chapter 5.1.1 today, so starting a brand new chapter. As we get started, a couple announcements for everybody. Again, reminder that Chapter 4 test is on this upcoming Monday, so less than a week away. Make sure you got your toolkit filled out. Make sure you got all your quizzes and homeworks done. Again, that's a great way to study for that test, is getting that homework done, especially. Make sure that closure assignment is taken care of. Again, makes your life a lot easier when you show up to take that test on Monday next week. Next announcement, if you did not pick up materials for Chapter 5, especially for all virtual students, please make sure that you come into the building as soon as possible. If you're unable to do so, please make sure you reach out to your grading teacher and let us know so we can work something out with you to get you the materials that you need to be successful in algebra. So today we're just going to jump right into Chapter 5, and we're going to start with a little warm-up problem, a little review for Chapter 4. So Ava and Patty were improving their yards by planting hostas and shrubs. So they went to the garden store together. Ava spent $60 on 6 hostas and 12 shrubs. Patty spent $36 on 12 hostas and 3 shrubs. What is the price of 1 hosta and 1 shrub? So let's figure out this one together here. So we need to, first and foremost, write a couple of equations. So let's make a couple let statements first. We're going to start by letting, let's say, H for the number of hostas. H is going to represent hostas. Since we know how many hostas each one purchased, and we're talking about money, we're trying to figure out the price for 1 hosta and price for 1 shrub, we're going to say that H is equal to the price per hosta, or how much one costs. So price per hosta. We'll just say the same thing for S, but we're going to let S equal the price per shrub. So we see Ava spent $60 on 6 hostas and 12 shrubs. So I think we should make one equation for Ava. And since Patty has another set of shrubs and hostas that she bought, we need an equation for Patty as well. So she spent 36 on 12 hostas and 4 shrubs. So what's the price of 1 hosta, 1 shrub? Let's write those equations out. All right, so Ava first. So she spent $60. Let's start with our total. So we have $60 is equal to, she bought 6 hostas, so 6 times the price of 1 hosta we'll call H, plus 12 times the price per shrub, where we have 12 shrubs. So there's our first equation. 60 is equal to 6H plus 12S. Now we need an equation for Patty. We've got our total of $36 spent is equal to 12 hostas. We have the price per hosta as H, so we have to do 12H, and then plus, again, we have 3 shrubs. Let's do 3 times the price per shrub, which is S. All right, so we have no variables by themselves, so I think our best strategy to solve this system is going to be elimination. So we need to cancel one of our variables here, and I'm going to pick, let's choose to cancel our H's here. So we need to multiply this top equation, the entire thing, by -2. Because we have positive 12 here, we got to make this a -12, so we got to multiply everything in here by -2. So I'm going to move this system over to the right and rewrite everything. So if we distribute that -2 in the top equation, we get -120 is equal to -12H, and then minus 24 times S. Bottom equation stays the same. We've got 36 is equal to 12H, and then what do we got? Plus 3G, or 3S. Now we can combine our equations. We'll add them together. So -120 plus 36 is going to be -84 is equal to, our H's go away. So we're left with minus 21S. And now we just need to divide both sides by -21, which means that S is going to be equal to 4. So that means we pay $4 per shrub. Now we just got to figure out how many dollars we're spending per hosta. So let's take that S and plug it in maybe into this bottom equation right here. and solve for the price per hosta. So that's going to be 36 is equal to 12 times H minus 3 times the price per shrub, which is $4. So now we've got, plus that. So now we've got 36 equals 12H plus 12. We've got to subtract 12 from both sides. So we get 24 equal to 12H. Divide by 12 on both sides. So we get 2 equals H, or our answer would be part B. So $2 per hosta, $4 per shrub. Good review of systems of equations, especially before our Chapter 4 test next week, Monday. All right, so let's jump into Chapter 5, 5.1.1, those brand new white packets. Basically, Chapter 5 is going to give us an opportunity to review and strengthen our algebra skills while we learn about arithmetic and geometric sequences. That's basically the big point or big part of this chapter. We're going to find ourselves using familiar strategies, such as looking for patterns, making tables to write algebraic expressions, describing sequences of numbers, and then later in the chapter, we're going to find some shortcuts for writing those equations for certain types of sequences. So a lot of fun stuff we can look forward to in Chapter 5. We're going to jump right into 5.1.1, though. We're going to get this party started with representing exponential growth. So in this course so far, we have been investigating the family of linear functions. That is usually multiple representations, mostly tables, graphs, and equations. But in this chapter, we're going to learn about a brand new family of functions and the type of growth it models. So we're going to start by looking at 5-1, multiplying like bunny. So if you've ever read the book of Mice and Men, if you're a sophomore or when you are in E10, you'll probably get to read Of Mice and Men by John Steinbeck. Two good friends named Lenny and George dream of raising rabbits and living off the land. But what if their dream came true? Suppose Lenny and George started with 2 rabbits, and then each month following, these rabbits have 2 babies. Also suppose that every month thereafter, each pair of rabbits has 2 babies as well. So with your team, determine how many rabbits Lenny and George would have after 1 year or 12 months. We're going to represent this situation with a written description of the pattern of growth, a diagram, and a table. What patterns can we find, and how do they compare to other patterns we have investigated previously? All right, so let's figure out some strategies that might be able to keep us on track with the number of rabbits. What patterns are we going to find, and how are we going to predict the total number of rabbits per month or per every month that's passed? So let's go to number 2 underneath. We're trying to find the total number of rabbits that Lenny and George would have after a whole year. Given, again, the fact that if they start with 2 rabbits, and every month after that, each pair of rabbits has 2 babies. So here we go. So how can we determine the number of rabbits that will exist after 1 year? We're going to draw a diagram to represent how the total number of rabbits is going to grow each month. So we have our starting at time is equal to 0. So like right now, at t equals 0, that's our starting point. We're going to draw a diagram. We've got 2 rabbits. 2 rabbits. So I'm going to put our 2 rabbits right here, just 2 red dots. 2 red dots. Now on the right-hand side, I'm going to put our total of 2 rabbits. So again, we've got 2. I was going to start writing total, but let's just put that as 2. This is our total. So this is the start of our table. We've got 2 rabbits. So now, after a month, that pair of rabbits has 2 babies. So now when we move down, we're at 1 month. 1 month in, we have still our original 2 rabbits. But those 2 rabbits gave birth to 2 little baby rabbits. So now we have a total of 4. So there's 1 month. We went from 2 rabbits to 4 rabbits. What's going to happen if we do that for 2 months? So now every pair of rabbits from the previous month is going to have 2 more babies. 2 more babies. So now the original 2 have 2 more babies. So there's the original 2. So I'm going to take these bottom 2, the children from before, I'm going to put them off on the right because they're now going to be parents. Those 2 are going to have two little baby rabbits of their own. So now we have 2 babies for this pair on the left. We got 2 babies on the right pair over here. And now we're up to a total of 8 rabbits. So far, so good. So again, every pair of rabbits from the last month is going to have 2 kids as we go to the next one. So now let's go to 3 months and see if we can diagram this out. So we got 3 months. Now every one of these pairs from the last month, so all 8 of these, every pair is going to have 2 more rabbits. So we've got 1, 2, 3, and 4 pairs now. So there's the 8 from the last month. All 4 pairs of those are going to have 2 more babies apiece. So we got to put 2, 4, 6, 8. So now our total, again, we had 4, 8, 12, 16 total for 3 months. Hopefully we're starting to see a pattern kind of develop here. But let's do 4 months as well. If we draw for 4 months, again, all of the babies from the last, or all of the rabbits from the last month, those pairs are going to make 2 babies per pair. So we need to put the parents, let's do those on the top. So we've got, there's 2, 4, 6, 8, 10, 12, 14. There's the 16 that were from month 3. Now all 8 of these pairs of parents are going to have 2 more babies. Now we're going to put 2 more for underneath each one of those. So 2, 2, 2, 2, 2, 2. All right, so now our total, we got 4, 8, 12, 16, 20, 24, 28, and 32. 32. So again, the kids become parents in the following month, and every time, or every pair has 2 kids, so we're kind of growing pretty quickly here. So if we were to do 5 months, we could keep going down. That's going to be a lot of rabbits and a lot of dots to draw. So let's see if we can find a little more efficient way to represent this growth. So let's go to the next page in our packets, part B. So like I just kind of mentioned, as we add more rabbits, the diagram becomes really cumbersome and really hard to draw because there's a lot of dots, hard to keep that stuff organized. So let's organize what we have so far. So we had 0 months, we had 1 month, we had 2, 3, and 4. And we had, on those months, we had started with 2 rabbits, then we went to 4, went to 8, went to 16, and then 32. So if we look, hopefully we can start picking apart this table and kind of find a pattern here. So if we go from 2 to 4, I think if we take 2 times 2, we can get to 4. If we take 4 times 2, we can get to 8. If we take 8 times 2, we get to 16. So between every single row of our column, we're multiplying the previous number by 2. So again, 4 times 2 is going to get us to 8. 8 times 2 gets us to 16. So if we keep that pattern going, now we can fill out the rest of our table and figure out the number of rabbits that we can get for a year. We got 5, 6, 7, 8, 9, 10, 11, and 12 months. So again, if we're doubling our number of rabbits every single month, let's fill out our table accordingly here. So if we start with 2, double to 4, double to 8, double to 16, double to 32. I think our next term we do 32 times 2 would get us at 5 months 64. If we take 64 times 2, we get 128. 128 times 2 is going to get us 256. 256 times 2 gets us 512. Next one would be 1,024. 2,048 is going to get us at 10 months. Now, if we double one more time to get us 11 months, we get 4,096 rabbits. And then lastly, after a year, we get 8,192 rabbits. So again, after 12 months, part C, we're asking how many rabbits for a total 8,192 rabbits, which is a lot of rabbits to take care of. But that's how many they want after a year. If they start with 2 and every single month every set from the previous month has 2 babies, so they're doubling the amount every single month after a year that have 8,192 rabbits. That's a lot of rabbits. So how does this growth in the table you've compared to growth patterns that we've investigated previously? How is it similar? How is it different? Well, previously we've looked at mostly linear equations, and linear equations always grow by the same amount between every input. So if our input here is our months, our output is the number of rabbits. We start with 2, we're going up by 2 here, then we go up by 4, then we go up by 8, then we go up by 16. So the big difference here is that we're not growing at a consistent rate. We're not growing at a consistent rate. So we're not, oops, let's fix that. We are not growing at a consistent rate. Where our growth rate seems to be increasing as we go forward in time. So that growth rate increases each month. And again, that we can see that because, again, every time we go up a month, we're multiplying that previous number by 2, so it's not consistent. We're multiplying by the same number every single time, but again, it's not a constant amount between terms. So we're multiplying by the same rate in between, but it's not a consistent number. All right, so let's go down to the bottom part of our page at 5-3. We're going to start this one, and we're going to finish this one on Thursday. But 5-3, Lenny and George want to raise as many rabbits as possible, so they have a few other options to consider. So they could do a couple different things. First, they could start with a larger number of rabbits, or 2, they could raise a breed of rabbits that reproduce faster. So how do we think each one of these options would change the pattern of growth you observed in the previous problem, and which situation might yield the largest situation or largest rabbit population after a year? So we're going to look at a couple different cases between today and Thursday. So today we are going to start with case 2. We're going to do case 3 and 4 and finish it off on Thursday. But today we're just going to look at case number 2. So to help answer these questions, let's model case number 2. We're going to start with 10 rabbits, and then each pair of babies has 2 per month. So each pair of rabbits has 2 per month. So let's start with a diagram again. In our table, we can probably label our months because we know we're going to have the same pattern over here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 months. If we're starting with 10 rabbits, we got to figure out how many we're going to have at the end of a year, starting with 10 rabbits, when each pair has 2 babies per month. All right, so let's draw our similar type table to what we did before. We've got our first month, or starting our initial, we have 10 babies. We're going to put our total over on the right-hand side yet again. So again, we're starting with 10. So let's draw 10 dots for our 10 rabbits that we're starting with. So 2, 3, 4, 5, 6, 7, 8, 9, 10. So for our first month, again, we're doing the same exact thing. Each pair has 2 babies per month. So we need to draw these 10 yet again with their 2 babies underneath. So we got those original 10. And their babies underneath. So now we got 2. So here we took 10. We're again having 2 babies again. So we got 4, 8, 12, 16, and 20. Let's do this one more time, see if we find a pattern at all. So again, now we got 20 rabbits in total. I'm going to see if I can make this go a little bit quicker. Let's pick a highlighter. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So those are 20 previous rabbits that were born or already were alive in month number 1. Each pair has 2 more babies. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20. So it looks like a pattern is starting to emerge again. Because if we count all those dots up that I just put up there, we're going to get 40 Yet again. So again, we're taking 10 times 2 to get to 20. 20 times 2 gets us 40. So I think if we wanted to write more terms down here, we could. But that's an awful lot of dots to write down. So let's just go with our pattern again, that we're taking the previous number and we're multiplying by 2 to get to the next one. So if we follow that pattern through again, our first 3 months we have 10. After 1 month we got 20. After 2 months we have 40. If we keep again multiplying by 2 to get to our next month, after 3 months we would have 80 rabbits. 4 months we got 160. 5 months we would have 320 rabbits. We'd have 640 for 6 months in. For 7 months we got 1280. 2560 for 8 months in. Next we'd have 5,120 at 9 months. We'd have 10,240 at 10 months. And the last 2 months we get 20,480. And our total after a year would be 40,960 rabbits, which is an awful lot of rabbits. So 4,960 rabbits after a year. Again, make sure you keep this close by. Don't lose this page, because we're going to compare this to what we get for our next couple cases on Thursday and try to figure out if we have a starter or higher starting value like we had with this case where we had 10 rabbits to start, or if we increase the number of babies that each pair has per month, what's going to get us the ultimate highest amount of rabbits, which we're going to investigate on Thursday some more. So last thing I'll leave you with for today is that the homework for tonight is the first section of the 511 homework. It's again that first section in our gold packet, 5-6 through 511. If you have any questions on that, please reach out to your grading teacher, especially if you can't get the materials. Otherwise, hope you guys have a great rest of your Tuesday, and we'll see you all on Thursday.